Today's class we are going to discuss the various error metrics which are used for classification model. If you want to evaluate the performance of any classification model, so let it be logistic regression or decision tree, whatever model or algorithm which we are used for classification, so we can use certain error metrics. So error metrics like we can use accuracy. Either you can use accuracy for measuring the performance of the model, or we can use confusion metrics, or precision, recall, F1 score. So in today's class, we are going to discuss about accuracy, what is accuracy, confusion metrics, precision, recall, F1 score. Okay. So accuracy is nothing but, so let's say we have a model, we have built a model. For example, let's consider, let it be logistic regression. So we have built the model and we have used the model for testing. So let's say we have considered 100 samples for testing. So 100 training examples, 100 samples or 100 training examples are used for testing. So out of this 100 training examples, let's say our model have predicted, so predicted output, it have predicted 90 training examples correctly. So, for example, if you're considering a classification, binary classification problem, which is having the output classes yes or no, or spam or no spam, or a person is having disease or not having disease. Okay, so that's the output class. So now, when we give 100 training examples, or we can say test data, we have given 100 test data to the model for prediction. So out of 100, the model have predicted 90 data correctly. So only 10 data has been misclassified. Okay. So accuracy of this model will be nothing but it will be 90 percentage. So 90 percentage or zero point 0.9. So accuracy will be calculated by considering the correctly predicted output by total total data given. So here in this example, it has correctly predicted 90 data out of 100. So 90 by 100, which is nothing but 90 percentage will be the accuracy. So this is how you calculate the accuracy of a model. So this is an important uh, metrics used for the performance of classification. Most probably for a balanced, if you are having a balanced data set, so we will come to the topic of balanced and imbalanced data set so later. So if you are using a balanced data set, most probably we will use this accuracy for measuring the performance of the model. So based on the accuracy, we can tell whether our model is good for prediction or whether it is not good for prediction. So the second matrix which we are going to discuss is confusion matrix. So confusion matrix, so it is also used to describe the performance of a classification model. Okay, so the name itself, it denotes that it is a matrix, or you can say a table. So normally it will be an n cross n table or n cross n matrix. So based on the number of classes present in the output, that denotes the n value. So let's say if we are considering a binary classification. So for binary classification, in the output we will have categories, right? So binary classification will have two categories. In such scenario, your n value will be equal to 2. So if you are going for multi-class classification, so if your output is having three categories, so n value will be equal to 3. So by default, so for understanding, we will consider a confusion matrix of uh, 2 class. Okay, so n value will be equal to 2. So based on the category or classes present in your output, this n value differs. So for binary classification, n value will be equal to 2. So for confusion matrix, we will form a table like structure. So this will be based on the true values calculated. So now let's consider, so let me draw how this confusion matrix table looks like. So now I am considering a binary classification. So my n value will be equal to 2. So I will be getting a true 2 by 2 table, a table consisting of 2 rows and 2 columns. Okay, so this is how my confusion matrix looks like. Okay, so here you will be having the actual value, and here you will be having, along the x-axis you will have the actual value. Okay, so actual value, actual, here you will have the predicted value. Okay, so now let's consider my binary classification is having, in the output I am having two categories, yes or no. Okay, so I'm considering a simple binary classification. My output is having two categories, either yes or no. So now I will be getting whether my model has, sorry, whether my training example is having the actual output is yes, my training example may have actual output as no, my model will provide the predicted output as yes, and my model may provide the predicted output as no. So these are the possibilities, right? So since I'm using binary classification, so in training example I may have the output as yes or no, that is nothing but actual values. So predicted is nothing but once the model is trained, so model will be providing some output, right? So the model may provide the output as yes, or the model may provide the output as no. So this is nothing but predicted output. So this is the confusion matrix table. So along the x-axis it will have the actual value available in the data. Here you will have the predicted value. So now we have four possibilities. So TP, FP, Fn, and Tn. So these are the four possibilities. So I will explain each term. So TP is nothing but true positive. Okay, so TP is nothing but true positive. True positive. So FP means it is false positive. False positive. So Fn in this sense, false negative. So it's an important topic. Please listen carefully. Tn in this sense, true negative. So these are the parameters present. So true positive, false negative, and true negative. Okay. So true positive in this sense, see, the actual output is yes and the predicted output is yes. If both actual and predicted output is yes, or you can say both are positive or both are yes, you can say it is true positive. That is, the model has given the right predictions. In the training example, the output is nothing but yes. Also, the model has provided the output as yes, which is nothing but true positive. Okay, so now false positive in the sense, the actual output is no. Actually, the output is no, but the model has given the prediction as yes. Okay, so it is a wrong prediction, right? So false positive in the sense, actual is no, but the model has given the prediction as yes. That is nothing but false positive. So this false positive is known as type 1 error. It corresponds to the type 1 error. Okay, so you may come across this type 1 error. So type 1 error is nothing but false positive. In the sense, the actual output in your data will be no, but the model has predicted, given the prediction or misclassification as yes. So now here comes false negative. False negative is nothing but actual output is yes, but the model have given the prediction as no. So this corresponds to the type 2 error. Type 2 error is nothing but false negative. Okay, so true negative in the sense, the actual output is no and the model has also given the prediction as no, which is nothing but true negative. Okay, so it's very simple to remember. So always remember that whatever term used here, so true positive in the sense positive, the this corresponds to the predicted value. So predict true positive in the sense predicted will be true means both will be same. Actual and predicted will be same. Okay, so here for true positive and true negative, there will not be any confusion, right? So both actual and predicted value will be same. So true positive in the sense actual, predicted will be positive, whereas true negative in the sense actual and predicted will be negative. Okay, so false positive. So for easy remembrance, you can just think uh, this corresponds to the predicted value. False positive means predicted output will be positive or predicted output will be yes. False negative means predicted output will be no. Okay, so or predicted output will be negative. Actual will be opposite to this. So you can remember it easily. So these are the parameters which are available in the confusion matrix. So from the confusion matrix, you can find the accuracy of the model. So if you want to find the accuracy of the model, so this will be given by the formula true positive plus true negative divided by all the entries true positive, true negative, false positive, false negative. So this will provide the formula for accuracy using the confusion matrix. So true positive and true negative are the correct prediction, right? So correct prediction divided by all the entries. So all the predictions provided by the model, which provides the accuracy.